Complex numbers are usually written a plus bi. A is called the real part and the bi is called the imaginary part. But the whole thing together, the a plus bi, is called a complex number because it's got a mixture of a real and imaginary part. Now if b equals 0, then what you have is that the whole second half will go away and the front half will just be an a, and that's just a real number. And so we will have only a real number. But if a equals 0, then that means the front half will go away, and you'll just end up with a bi, like 3i or 4i or something like that, or negative 2i. And then you have what's called a pure imaginary number, because it doesn't even have the real part in the front. Now let's look at doing operations with two complex numbers. First we'll do adding, then we'll do subtracting. So remember, a complex number is in the form a plus bi, which each of these are complex numbers, and they're being added together. The nice thing about this is it's really nothing new that you haven't done in the past. It's really a lot like combining like terms. So what you can do is put the two real parts together, which are the 4 and the negative 2, add them together and you get positive 2. Then you can separately take the imaginary pieces together, and you have basically a negative 3i plus a positive 5i, which gives you a positive 2i, and so we can just put that next to the other 2. So this answer is also a complex number, and that's the final answer, and it's the sum of one complex number and another complex number. Subtracting two complex numbers also has the same properties as if we were combining algebraic expressions. So what we want to do is be careful with this negative, or this minus sign. What we want to do is change the signs of everything after it. I call that add op, which means add the opposite. So anytime you see a subtraction, you can change it to adding as long as you change everything that it applies to the opposite of what it was before. So we're going to change both of these to the opposite of what they were. And so we're going to change this to a positive 2 and this to a negative 5i. So subtracting this expression means adding the opposite of everything in that expression. Now we can just add like terms like we did on the one above, except the numbers will turn out different because what we have is a 4 plus a positive 2 now, which makes that a 6. And then we have, you can think of that as a negative 3i plus a negative 5i, which makes a negative 8i. So that is the complex number that represents the difference of the two expressions that we had in number 1. Number 1, we did the sum of two expressions, then we took the same two expressions and did the difference, or the subtraction of, and we got a different answer. Now let's do the multiplication of the same two expressions or complex numbers that we had in the previous example. This looks like something else we've done before, and a lot of us will call this FOIL because it's a binomial times a binomial, and the most organized way to do those times each other would be to do the FOIL process. So let's put F, O, I, L and get some sub-answers for this. So first times first would be negative 8. Then we do the outside ones times each other, the farther outer edges, and that's a positive 4 times a 5i positive, so that is a positive 20i. So we'll just put a plus in between those two expressions. Then we go to the inside, which would be the middle two, the ones closest to the center, and you want to picture that like a negative 3i times a negative 2, which gives you a positive 6i in this case. Negative times negative is a positive. And then finally we do our last times our last one out of each parentheses. You want to see that as a negative 3i being multiplied by a positive 5i, which gives us negative 15i to the second power, because I times I is I squared. Oftentimes in foiling, we end up getting the middle two terms as like terms that could be put together. So let's do that. Let's write -8, put together a positive 20i and a positive 6i, and we get a positive 26i. And then let's write 15, but on a previous lesson, we found out that I squared equals -1. That would be something you'd want to just memorize because that's going to be used a lot. So I squared is the same thing as -1, which makes this -8 plus 26i. And if you think of this -15 getting multiplied by that -1, you get a positive 15. And we have one more step now that we couldn't do before, but now that we have two real numbers in our problem, we can put those two real numbers together. And we get 7 plus 26i. That's as far as we can go because we can't put a real part and an imaginary part together. They're not like terms. We just leave them separate, and it's better to write I than to write square root of -1. I is a simpler version of that, but whenever you have I squared, it is simpler to write -1 instead. So we don't want to write square root of -1 when we could just write I. Dividing two complex numbers is probably the most complicated operation that we need to do. You might have to watch this a couple of times to understand what I'm doing. There's a trick that you can't divide the 4 divided by -2. You're just not allowed to do that. So the trick is that you're going to take what we call the conjugate of the bottom. The conjugate of the bottom leaves the first number the same, but changes the sign in front of the second half of the number. That's called the conjugate. And the conjugate gets multiplied by the denominator. This is really the only way we can simplify this problem. They don't like i's to stay in the denominator most of the time, because if i's are in the denominator, that means an irrational, imaginary type number is in the bottom, and we like to keep our denominators as rational integers if we can. So if you decide to multiply the bottom by the conjugate, you can't just do the bottom and change it. We have to do something that will balance it out, which means we also have to multiply the top by the exact same complex number. Because in a sense, if you think about it, this, something on top of itself, just is the same thing as multiplying by the big number 1. And multiplying by 1 will not change the value of anything, it'll just change the looks of it. So what we're going to do is we're going to FOIL the top and FOIL the bottom and see what we end up getting. As you can see, if I FOIL the top and I FOIL the bottom, you can pause and follow the steps and try it on your own. There is a place that we end up with a 15i squared and a -25i squared, which notice over here I change the I squared to a -1, I multiply it, and I end up with a -15. When I multiply the 15 times -1, I end up with a positive 25 when I multiply the -25 times -1, and therefore I end up with an answer that looks like this when I simplify and combine like terms. Now, that is not technically in the form a plus bi, and sometimes they prefer that you leave it in the form a plus bi, and to do that, all you do is split your fractions to where you put each numerator part over the common denominator and reduce the fractions if that is possible. And then you just kind of stick the I over to the side rather than having it on the top, and then it perfectly looks like a plus bi form.